This screencast is about the voltage divider. A voltage divider is useful to measure voltages or resistances. So let's say you have a variable resistor like this. That could be a light resistive resistance, or it could be a potentiometer. You would like to measure its resistance. You can hook it up to a microcontroller's ADC input port like that. And then apply 5 volts to it. So now what happens, you will only measure 5 volt at the ADC. So let's say this is U out. So what you can now do is you can put an additional resistor here. Let's call this R1 and let's call this one Rx. And you put 5 volts over that. And now you can actually change U out as a function of the value of Rx. How is this going? Well, let's consider there's some current flowing into the circuit. So using Ohm's law, we can write down U in. We can write down that U in equals R1 plus Rx times I. So these two resistors are in series now. Also, we assume that this resistance here, this current here, is 0. This is because the resistor that is inside this microcontroller is usually very, very, very high, and as I equals U divided by R, a very high R will lead to 0 current, or close to 0 current. So as the current going into the ADC is 0, the current that goes through Rx is the same as the current that goes to R1. Now we can also write U out equals Rx times I. Now we can actually substitute the expression for I that we get from this equation into that equation, and we get something like this. Let's get rid of this. U out divided by Rx. So now we see we have an expression that relates U out to U in. Now let's write that down a little bit better. We can actually bring these guys to that side and that guy to that side, and we get an expression like, let's make some room here. We can write down an expression like this. U out equals Rx divided by R1 plus Rx times U in. So if you have a voltage divider like this, and you have your variable resistor here, and you measure the voltage here, then U out is a function of Rx and U in.